Okay, my name is Wisdom Omuya, and I work as a software engineer at MongoDB, and I'm here today to talk about Go vendoring. So let's take a step back and ask ourselves, what exactly is vendoring? Thanks, Kelsey. He actually covered a big part of what I was going to do for the intro, so that's great. But as most of you here know, there are a bunch of different package managers in different programming languages. And what they do essentially is when it's time to build your project, they go perhaps to the internet, they download the dependencies for your project, and then use those dependencies to build your project. Now, in the Go ecosystem, the Go community, we take a kind of slightly different approach, right? So instead of having those dependencies downloaded from some repo, we instead have them live within your project. You can imagine some issues with the traditional approach of using package managers, right? So what happens if your repository system goes down? You know, everyone just grabs a cup of coffee or just lazes away at work until it comes back on. The service shall not be named. So we are all used to things like that, right? And there are also situations where the library author could, for whatever reason, decide to take the package down, left pad. So this is something we're all familiar with. And vendoring solves a lot of these issues for us, right? Now, I know this is a very contentious issue, so I'm not going to spend a lot of time arguing about the relative merits and demerits of vendoring, but it's where we're moving as a community in Go. So this is what I'm going to cover today. I'm going to start with a fairly basic introduction to what vendoring is, specifically as it pertains to the Go programming language. We'll go into a bit of the details of how exactly it works in practice, and I'll leave you with some of my suggestions on how we should use this in practice moving forward. Now, a big reason why I decided to talk about this was because we had issues before this feature was introduced within Go with how we manage our third-party dependencies. And raise your hands if you have had a similar problem with vendoring third-party packages, right? This is, OK, not as many as I thought about. OK. So to help illustrate what the problem was, we started with a project directory that looked like this. So this is a project called Mongo Proxy. It's written in Go. And essentially what it is, as the name implies, a proxy for MongoDB. It essentially accepts requests to the server, and you, in turn, can write a bunch of modules that, in some cases, may send it to the database itself, or you could use this to route it to some business intelligence tool. So in this case, I have a single module, so this is kind of pointless, but all it does is it takes requests and then forwards it directly to MongoDB using some configuration. Now, here you notice I am vendoring a single library. This is the Mango library. It is the Go driver from MongoDB. It's essentially what allows you as an application developer in Go talk directly to our database. Now, this is kind of how we started out before this vendoring feature, right? And so if we wanted to build our project, as we know, the first thing we want to do is to export the Go path, right? In this case, I sent it to the Mongo proxy directory. However, if within my proxy.go file here in my MongoDB module, I attempted to import that Mango library, this will bug out, right? Because the Go compiler wouldn't be able to find that Mango library. So this was a problem. If you've used Go to build projects that have third-party dependencies before the new vendoring feature came out, you probably are used to this problem. Now, there are a number of tools that help with this before vendoring, but we kind of took a different approach to solving this. The first thing we did was to create this scaffold directory called .gopath within our repository. And then within that, we had the source directory and then a Mongo proxy directory. Now, I know you're thinking this is horrible, and I agree. It was horrible. But this wasn't all. After we did this, we then symlinked that directory to the top-level repo to ensure that, you'll see why this was necessary, to ensure that whenever we reference that as imports in our programs, it found the right thing. And then finally, we rewrote our Go path, right? So we appended both that symlinked directory to the vendor directory. Now you note that these two directories have a source subdirectory within them, and this is required because when you're importing packages, the build toolchain first looks within your Go path, and then underneath that, the source directory. And so this was kind of how we did this. And we ended up with a build script that looked like this, right? So we'd first go to that directory, we'd clear out the Go path, we'd recreate the scaffolding, symlink it, and then rewrite our Go path before we could finally build. Now, as you might imagine, we really didn't like it, right? It's pretty ugly, it's not maintainable, and it kind of felt wrong, right? Like, I'm a big fan of simplicity and minimalism, and this just went against that whole Go ethos of simplicity. So we kept asking ourselves, well, can we do better? Without support for this feature within the language, we kind of were stuck with where we were until about a year ago, we read this, right? It says, vendoring. Go 1.5 includes experimental support for using local copies of external dependencies to satisfy imports of those dependencies, often referred to as vendoring. And this is a mouthful, but basically what it says is you can now just copy your dependencies to your repo and things will just work. As you might imagine, coming from where we were like super psyched. We were like, this is great. We were super excited about this. Now, once we got over our initial excitement, we took time to sit down and figure out, well, how exactly does this work? And so for the rest of this talk, I'm going to first cover how import resolution works before the new feature was introduced, and then we'll look at how things have changed. So if you're using any version of Go on or before 1.4, the way your import resolution typically works is the build toolchain first looks within your Go root, right? So this is an environment variable that tells it where to find your standard packages like HTTP, thumb, and encoding, and all these packages. Now, if it's unable to find your dependencies in that directory, it then looks within your Go path, right? This is what you set typically on a per project basis, where you have your own application you're developing and possibly any third-party libraries. Now, with vendoring, things have kind of changed a little bit, right? So the first place the build toolchain will look for to satisfy the resolution for your imports is within the vendor directory. And this is in your Go path, right? So this is within your project, that vendor directory. So this has a number of implications, right? If you are an author of a library that by default has certain packages within that folder, the semantics of how the build system interprets that changes. Now, if the build system is unable to find your dependency in that directory, it then goes further up. It walks a tree into the parent's vendor directory. Now, if it's unable to find it there, it does that iteratively until it hits your Go root. So this is kind of a little bit confusing, but that's how it works. It keeps climbing up until it hits your Go root. We'll see a bit of an example of how this works later on. So what happens if it's unable to find it here? The next place it looks is your Go root. This is similar to the behavior before the vendoring feature, and if it's unable to find it there, it goes to your Go path. And if not, your program doesn't compile. OK, so that's how it works. For the rest of this talk, I'd like to first give you a brief overview of how things have changed from a holistic perspective. Now, as I mentioned, if you're using 1.4, this doesn't exist, so you don't need to worry about it. It was never an issue. And as I mentioned earlier in the announcement, it became an experimental feature in Go 1.5. So you basically set this environment variable, Go 1.5 vendor experiment to 1, and that import resolution technique kicks in. Now, you can opt out. By default, it opts out. It's not enabled in 1.5, but if you want to test it, you just set that. However, in 1.6, it is the default. So those of you who are using 1.6 are probably already familiar with this behavior. But you can still opt out, right? So all you'd have to do in 1.6, if you weren't cool with it using this feature, is to set that variable to 0, and it doesn't work the way it works in the new resolution author. And finally, and this is kind of why this is really important, it's where we're moving as a community. And so in 1.7, you're not going to have any option to opt out if you wanted to. Of course, you can always decide to put your dependencies in some different folder, but as a standard default, it's not going to be possible to not use this feature. So it's important that we all, as developers, understand how it works and standardize on it. OK, the next thing I'd like to do is go over a few of the details. Now, everything I'm going to talk about in terms of details comes directly from the specification for this new feature. If you're interested in learning more about it, you can go to that URL and you can learn it. It's pretty simple, as with most things in Go. It's just 4 pages. OK, so the first detail I'd like to look at is this. It says, if there is a source directory d/vendor, then when compiling a source file within the subtree rooted at d, import p is interpreted as import d/vendor/p if that path names a directory containing at least one file with a name ending in .go. Yeah, it's a lot to take in. It took me a while to understand what this means, so I'm not going to have you stare at this for too long. So let's try and understand this using an example. So this is the same Mongo proxy project I mentioned earlier. I've simplified things a little bit. In this case, we only have a single third-party dependency, the context library, and we have a main.go file. Now you see I've exported my Go path as home/projects, and so if I'm building my tool, building my main.go file, it should directly be able to find both packages within my project and my vendor packages. Now to illustrate how that resolution works, let's take a look at import statement you might ordinarily have written before this feature. Now this goes within my Mongo proxy project, my vendor directory, and then references the context library. Now that first detail says you never use the long form, right? So you never need to include that Mongo proxy/vendor in your import statement in any of your source file. So this is pretty nice, right? It's pretty simple. It just works seamlessly, and we have a very clearly defined order of resolution for our import statements. Now, what happens if I have this in my main.go file? Well, it resolves to that package automatically. Note here, I don't need to do any scaffolding or symlinking or some hacky stuff to make this work. It just does the right thing out of the box. So this is great. Now, the fine print here says there must be at least one .go file, right? So what happens if I remove that file? Now you note that the scaffold, the structure here, the directory structure for that context package still exists. However, if I try to build this package, it bugs out, right? It says it can't find that package. Now that's because of that fine print that says it must contain at least one .go file. OK. In other words, to put it simply, what that first detail just says is your vendor import paths must always use the short form. So you never need to include the name of your project/vendor when you're importing third-party libraries. And there's the fine print about the .go files. Now, moving on to a second detail here. This is kind of easier to grok. It says when there are multiple possible resolutions, the most specific or longest path wins. What exactly does this mean? Let's look at an example. So here, you see in addition to my vendor context library, I have a top-level context library in my Go path, right? So the question is, if within my main.go file I have an import statement for that context library, what exactly would this resolve to? Well, I can see I have two candidates, right? One's within my vendor folder and the other within my Go path. Now, based on the new import resolution rules, the one that's within my vendor directory is what that import statement gets resolved to. OK. To put this simply, it basically says the most specific resolution path wins. So, and you'll see this in the next example, the longer the path is to the source of the import statement, the more preferential it is in the resolution of that import. And so that brings us to our third rule, right? It says the resolution of an import must now take into account the location where that import path was found. This kind of sounds obvious, right? Like it's expected, but we'll see exactly what this means in more detail. So this is a slightly more complex example. I have, in addition to my vendor folder there, a server package in my Mongo proxy project, which in turn vendors the context library. Now, if within my main.go file I decide to import that server package, we already know this will resolve to that package there in my project. But what happens if within my server.go file I attempt to import the context library? Now, this is more interesting, right? Because we've got three potential candidates here. We've got the local vendor copy of the context library, the vendor copy within my Mongo proxy project, and finally, the version of that library within my Go path. Now, as you might have guessed, this resolves to that local copy of the vendor context package. Now, why is this important? As I mentioned earlier, we're trying to move as a community to the place where vendoring is a first-class citizen, and it's something that it's widely adopted in the community. If you were a library author and you vendor packages in your project, and you in turn release that project for other people to use, you'd want your program to resolve its import to your local copies of your vendor library and not that of perhaps the person who was using your package. So even though this might be a bit counterintuitive at first, it's exactly what you want. Now let's look at a slightly different example with how this feature works. You remember the second place the build toolchain looks for dependencies is in the parent's vendor directory. So in this case, in my service.go file, I can see I have an import statement for that context package. Now you note here that it in turn is within a vendor folder for the server package, and that import could possibly resolve to two things, right? It could either resolve to the top-level context library or the vendor copy of the context library within my Mongo proxy project. Well, what does it resolve to? Well, based on the second report resolution rule, we know that it should resolve to that vendor copy within the Mongo proxy project. Now, this makes sense, right? Because the first place it would look is within the vendor directory of my server package. It doesn't find it there, and so it walks one directory up within my Mongo proxy project and then finds that library within the vendor directory there. OK, now to put this simply, the closest resolution just always wins, right? So if you're trying to figure out what exactly does this import statement resolve to, you can just think the most proximal package that it could resolve to within your list of possible packages is what will get resolved. OK, now the last detail I'd like to take a look at is this, and this is the most interesting. It says if someone wants to vendor and therefore hide the standard library version of math or even unsafe, they can. OK, so here's an example. I have a vendor folder here with the Mango library vendored, and within my server.go, I have an import for the thumb package. So will it compile? Yes? Yeah, it will. And this might be either very, very funny or like unbelievably scary, depending on your sense of humor. But this has really far-reaching implications, right? Because it means if for whatever reason within your workspace you decide to do things weird, and for your vendor packages, you have import statements that reference things that exist within your Go path, but not within the vendor tree, those imports will get correctly resolved, and it could cause a disaster in production. So it's just something to keep in mind. Short form of this basically says, if you can, just try not to shadow standard library packages. That's not cool. Yeah. OK, just to recap, these are like the 4 details we've looked at so far. The vendor import path must always use the short form. The most specific resolution path wins. The most proximal path also wins. And if you can, try to avoid standard library packages as to avoid shadowing that. Now, as programmers, we all work with details, right? That's kind of what we live for. Like the 90% case is always easy. It's the 10% you have to like really hone in on and make sure you get right. And so we know the devil is in the details. I'd like to just have everyone just give a round of applause to the Go team. I think this vendor feature has worked really well. So just a round of applause for them. Yeah. In preparing for this talk, I could only find one fairly, I wouldn't call it a bug, but an issue with the way it works that might catch a lot of us off guard. And so I just wanted to take a time for us to look through an example and see what the issue here is. So to help illustrate that, I have the same Mongo proxy project, but in this case, I have an interface here called dbwriter, right? This is within my server.go file within the Mango package. Now, you can think of it as just a simple interface that allows the client to send it some bytes it wants to write, and then, like any write method, it returns a number of bytes written and an error if there's any. So this is me as an application developer, right? Like I'm developing this library for people out there to use, and let's say within my Mongo proxy.go file here, I have a proxy writer interface, right? So since I'm writing a Mongo proxy, I'd like people to be able to give me different DB writers and then route those writes according to whatever rules they have. Now, the important thing to note here is the DB writer interface that goes in as an argument to my route write call is an instance of the vended library version of the Mango library here. This is a really important detail, as you'll see later on. Now, let's say I finish writing this. I've written all the tests. I'm pretty confident it works for most use cases, and I go ahead to release it. Now, say like an average Joe goes ahead and says, wow, Mongo proxy is pretty cool. I'd like to use it in my project. And then they do something like this, right? So here they have their own main application. They'd like to orchestrate the way requests are handled in your application such that they use Mongo proxies to route them in special ways. And so they go ahead to vendor both the Mango library, which enables them to talk directly to the database, and then my application, the Mongo proxy application. Now, the interesting thing to note here is you have 2 versions of the Mango library here, right? One within their own vendored library, and then one within my vendored project, the Mongo proxy project. Now, as you might imagine, the vendored copy I have within my project will resolve to will resolve correctly for any imports I have in my project. But what happens if they want to implement my route write interface, right? So they might go ahead to do something like this. So they import both my vendor Mongo proxy package and the Mango driver there, and they have, in this case, a proxy writer struct that implements the proxy writer interface, Mango writer struct that implements the DB writer interface. And so it all looks pretty good, and then they go ahead to implement my proxy writer interface by calling my proxy writer.routeWrite on the Mango writer. Well, it actually doesn't work. And the question is why? The key things to note here are just two last lines there. It says what it wants is a vendored copy of my DB writer, but what it has is a vendored copy of this application developer's DB writer. This is a problem. There's essentially no way around this. There is a way around this, but there's no way they can import the vendored copy of my DB writer from the Mongo proxy project. I didn't mention this, but one of the rules with regards to this new feature is none of your import statement can contain a /vendor/ in your import path. And this kind of goes with the first detail, which says you must always use the short form. So this is a problem. Well, how do we solve this? Now we've kind of covered a bit of the details of how it works. We know a little bit about some of the quirks and some things to keep an eye out for when we're using this in production. The last thing I'd like to cover is, well, what exactly doesn't it do? Now, we talked about package managers and how things are typically handled in other languages when it comes to dependencies, but the Go vendoring feature is just a feature of the language, right? It's not a package management tool. It's not going to prevent you from making multiple import statements within your programs or having multiple versions of the same package in your project, and it's certainly not going to help you go get them, right? If you have these issues, and this is something most of us will probably run into, I recommend you use one of these tools that I've used, and I can recommend based on my experience that I feel are pretty cool and work directly with the vendor feature. Glide kind of works with the Go toolchain. GB, which I think is Dave's project, takes a different approach with how it interfaces in your project. Now, in terms of how you should use this, we saw this problem initially, right, where if we have interfaces or functions that are vendored and we expose that in our libraries, our end user might be unable to use those in their projects, right? So how exactly do we solve this? I'm not sure. One possible option might be to wrap those interfaces or function calls with types within your own library, and so the user can then implement that directly. But I'm not sure how exactly to solve this. I think there was a Google group discussion that started on this issue that hasn't really gotten resolved. Another thing to keep an eye out for is if you can try and avoid vendoring multiple versions of the same package, and if you must, you should definitely try one of these proven vendor management tools that help you resolve those things in your projects. Now, I'd like to conclude by just reiterating how important it is that we all as a community get to use this feature. Some of the good things it does for you, as we already know, is it helps you avoid any import path rewriting or any hacky solutions to take care of third-party dependencies in your project. It does have a very clear rule with regards to how it resolves multiple candidates for your import statements in your programs, as we saw earlier. And last, but certainly not the least, is it provides a standard, right? We all have our varied ways of handling dependencies in our projects, and I believe in just having a single canonical way of solving problems, especially for something as ubiquitous as vendoring. And I think it's important that we all, as developers, go ahead and use this standard in our various applications. Now, just to go back a little bit, this is where we started in the Mongo proxy project without vendoring. We had a working directory that was really hacky with this scaffolded path, this symlink, and this weird Go path we had there. Now, with the new vendoring feature, we're able to avoid that symlinking. We're able to remove the need for any scaffolding. And we never had to rewrite our Go path, right? So we started off looking like this, and we ended up here. And I don't really like build script. I like simplicity. And so we were able to come from a place where we had a build script that looked like this to a simple one-liner that looked like this. And that's the end of my talk. Thank you.